So next we think through what happens when we multiply the x value in the expression for a function by a constant c. And if you think carefully about it, if the c is bigger than 1, then this basically shrinks the graph horizontally. So it cuts the distance from the y-axis of any particular point on the graph by a factor of c, or it's the same as multiplying that distance by 1 over c. And if c is between 0 and 1, it expands the graph. So again, it multiplies the distance from the x-axis of any particular point on the graph, the distance from the y-axis of any particular point on the graph by 1 over c, which is now greater than 1 if c is less than 1. Let's see what happens in the case of y equals the absolute value of x. So we can easily fill in these numbers here. Just take absolute values. And then if we take the absolute value of x over 2 here, we just basically cut the absolute values in half here. This is 0.5, 0, 1, 1.5, 2, 2.5. And if we take y equals the absolute value of 2x, and for having any given x on the graph, it multiplies the absolute value by 2. So this is 10, 8, 6, 4, 2, 0, 2, 4, 6, 8, and 10. And now let's sketch these graphs. And what you see here is for any given y value here on the graph, say 4, then the point corresponding to that with the same y value here has double the x value. So if you consider these 2 points, the point minus 4, 4, the graph of y equals the absolute value of x, the point minus 2, 4, and the graph of y equals the absolute value of 2x, you see they're the same height above the x-axis, but this one is half the distance from the y-axis of this one. And so similarly, 0, 0 is right on the y-axis. This point here is half the distance from the y-axis of the corresponding point here, where the x value is minus 2 and the y value is 2. And similarly, we have, these are the points which are half the distance from the y-axis, but they have the same y value in both cases. But the x value here is half the distance from the y-axis that the x value is here. And dividing by 2, we get, it doubles the distance for corresponding y values here. Let's take 2 minus 4, and these have the same y value, but this point is double the distance from the y-axis that the one on the original graph is. And likewise, this one with y value equal 1 is double the distance. Here the distance from the y-axis is doubled, doubled, and doubled. So this is what we mean by stretching or shrinking horizontally. We divide by 2. It stretches the graph horizontally by a factor of 2. And if we multiply by 2, then it stretches the graph horizontally. It divides the distance from the y-axis by 2. So it shrinks the graph horizontally by 1/2. Let's draw these functions. Y equals the absolute value of x is easy. You should have an idea of what the picture looks like already. I think I'll draw the function first before I put in the y values. This one's 1, this one's 2, 3, 4, 5. So we have the point -1, -1, -2, 2, -3, 3, -4, 4, -5, 5. Same points here. Okay, maybe we need to change things just a little there. And that's the graph of y equals the absolute value of x. Now let's look at y equals the absolute value of x over 2. Well, this first one, -5, 2.5, it doesn't have a corresponding value here with the same y value, so we don't have anything to compare that to. But this point, -4, 2, is basically this point with the distance from the y-axis doubled. So you've basically taken this distance in the y-axis and doubled it. And this point, -2, 1, is a shift of this one by multiplying the distance from the y-axis by 2. And then you have a point in between here which would correspond to 1.5, 1.5, and basically you double the distance to get this point here on the graph of y equals the absolute value of x over 2. And of course, 0 distance becomes 0 distance when you double it, and the point -1.5 is the point 0.5 with the distance doubled from the y-axis here. So this is basically a doubling of the distance of this original absolute value of x from the y-axis. The same thing here, this point gets pushed out to the point 1.5, and this one gets pushed out to the point 2.1, and basically there's one between here which gets pushed out to the point 3, 1.5, and then this one here 2, gets pushed out to the point 4.2, double the distance, the x value, and basically this point 2.5 on this graph gets pushed out to the point 5, 2.5. And so the distance from the y-axis gets doubled when you're drawing this graph. And likewise, when you draw the graph of y equals the absolute value of 2x, you're halving the distance of the points in this graph from the y-axis. So the point -510 doesn't correspond to anything on this graph. It's way up here, and it corresponds to a point over here, 1010 on the absolute value of x, with its distance from the y-axis cut in half. The point -4.8 again doesn't correspond to anything that we have here. It's basically the point 8.8 on the graph y equals the absolute value of x, with its distance from the x-axis halved, or from the y-axis halved. And the point -3.6 again comes from a point -6.6 on this graph, with the distance from the y-axis halved. But now we have our points here kicking in, so the point -2.4 is what we get when we take this point -4.4 and we halve the distance from the y-axis. Maybe that one should have been there. And the point -1.2 is what we get when we take this point 2, 2 and cut the distance from the y-axis in half. Point 0, 0 stays where it is, so you end up with a straight line again, which looks like this, with basically its distance from the y-axis is half the distance of the graph of y equals the absolute value of x. And the same thing on this side, we get the point 1, 2, which is basically that one, with its distance divided by half, 2, 4, and so on. We get a point up here. We're going to get 3, 6, etc., etc. So that's a graph of y equals the absolute value of 2x, and the distance from the y-axis is cut in half. The distance of the function y equals the absolute value of x, and basically it's shrunk this function towards the y-axis.